key thing is this. Remember when we're doing the sine function, which looks like this, we take the principal sign comes from here to here, from minus pi over 2 to pi over 2. Okay, this is the principal sign. That means that when you do the arc sign, it takes you back to between minus pi over 2 and pi over 2. The r here's minus pi over 2, and here's pi over 2. Here's pi. The arc sign takes you back to between here and here. When I do that arrow, that means between here and here. The arc sign. That's where it takes you back to. Okay, let's look at the cosine. Cosine function looks like this, and the principal cosine is here, between 0 and pi. So the arc cosine takes you back to an angle between 0 and pi. The arc cosine takes you back between here and here. Okay, that's two of the functions. How about the tangent function? The tangent function is just like the sine. The principal branch is this branch that comes like this. These are asymptotes here. So that's the principal branch. The arc tangent takes you back between minus pi over 2 and pi over 2. Okay? And now let's look at the... so those are the ones that are always on the left side, right? Sine, cosine, tangent. Then look at the other, cosecant. Cosecant looks like this, like this, and like this. These are asymptotes here. And the principal we take is right here. Again, it's this part and this part. So it also takes you back between minus pi over 2 and pi over 2, although it never hits 0. So the arc cosecant is here. Now the arc cotangent, notice that the sine and cosecant, the arc sine and arc cosecant go to the same, take you back to the same place. If you look at the secant also, the secant looks like this, and like this. Here's your, secant looks like this. Comes like this, and like this. And this is our principal secant, is right here. So between 0 and pi also. So that's the same as this one, arc secant. If you'll notice that so far the functions and their reciprocals, cosine, secant, sine, cosecant, their inverse functions go to the same, back to the same, but the cosecant is, the cotangent is different. The cotangent, and why is that? Why does it not go to the same place that the tangent does? We take it for the principal to be this here, this between 0 and pi, so the arc cotangent also comes here. Okay. The reason is because we could have taken it the other way. We could have done it, here's pi over 2. We could have done minus pi over 2. And here's minus pi. And it comes like this, right? And we could have taken this branch and this branch. We could have. But why split it in half like that with an asymptote in between? Why not just take a full branch? It's nicer. So that's why it's done. But as a result, you get 3 of them. The arc functions, the sine, tangent, and cosecant go back to angles between minus pi over 2 and pi over 2. And these 3, the arc cosine, arc secant, and arc cotangent, go back to angles between 0 and pi. Okay? So that tells you something about when you're just undoing things, you have to be careful. When you take the arc function on the outside, you got to be careful because it only takes you back. It's one of these 3, only back to here. So if you took the cotangent of 7/6 pi, right? It's right here. That's minus 30 degrees. 7/6 pi. You took the cotangent of 7/6 pi and then did the arc cotangent of that. You're not going to get back to 7/6 pi. They do not undo each other when this is outside the range of the arc cotangent. Arc cotangent goes between here and here. So it won't go back to this.
Is that an invalid statement then?
What's that?
Is that equation invalid?
Well, I haven't said anything yet.
Oh, okay.
I mean, I just labeled this point. I haven't said what this is. So now, but here, notice that the cotangent here is what? The cotangent here is what sine? All you have to worry about is the sine. It's going to be at a 30-degree angle. Here's the 30, here's 5/6 pi, and here's 1/6 pi. Right? Actually, this is a straight line going to 1/6 pi, right? So which one does it take you back to? The cotangent of 7/6 pi is positive or negative?
Negative. No. It's negative, positive. It's two negatives, so it makes it positive.
That's right. Cotangent's based on these two values here, and they're both negative. So cotangent's this over this, tangent's this over this, cotangent's this over this. So this is negative over negative is positive. So the cotangent, this cotangent value will be positive. Whenever you have a positive value for all of them, positive value goes back to the first quadrant. All of them. All 6 of them. Because this goes from here to here, this goes from here to here. Here's where the negative values occur, here and here, and here's where the positive values. Everything's positive in the first quadrant. So this would be pi over 6. So that's where you have to be careful when the arc function is on the outside. That's where you have to be a little careful. On the other side, you don't, because remember, if you have the cotangent of the arc cotangent of 55, you say, well, there's no, yeah, this is a cotangent value. This stands for the angle. This is the angle whose cotangent is 55. Well, cotangent runs from negative infinity to positive infinity. It's on all possible values. So you can put any number you want in here. Absolutely any number you want. And if you take the cotangent of the angle whose cotangent is 55, well, you get 55. So in that direction, there's no problem. If the trig function is on the outside, you just get back the argument, period. For all of them. But if the arc function is on the outside, you have to be careful. Be sure it's in one of these two quadrants for these three, or one of these two quadrants for these three. And between these values, because there's lots of values in this quadrant, you can go from 3 pi over 2 to 5 pi over 2. No. It's between minus pi over 2 and pi over 2.
Do you mind doing a trivial example like arc sine of 3 pi over 2 and walk us through it?
Arc sine of 3 pi over 2.
I think that's in the range.
Yeah. Well, 3 pi over 2, of course, is a number, because arc sine gets applied to a sine value. It's got to be between minus 1 and 1.
Right, so arc cosine of 3 pi over 2.
But both sine and cosine are between minus 1 and 1.
Oh, I see what I'm saying. Yeah.
I know, I get confused with this too. I sometimes
2 pi over 3 then. Yes.
2 pi over 3, but pi is bigger than 3, so 2 times 3 is 6 divided by 3 is over 2, so you can't take the arc sine of that. Unless you want to use complex numbers, you can actually take the trig functions of
What the hell is that?
other numbers. What's that? Something alive?
A spider.
Yes.
Oh, look at that. Daddy long leg. He's on his way. He's on a mission. Hey, get away from me. He's on a mission. He's on a mission from God. Okay. See, that's what he does. Okay, so I'm going to joke. Otherwise,
It's boring.
okay, so I'm trying to think of, from trig, an equation you want to solve. Shoot, I don't want to take too much time, but we got to get on with it. I'll think of an example, I'll bring one in right off the top of my head. Now I'm thinking of working, remember if you had trig, you had these problems where
You want to take one of the problems
where
from...
you had, sine squared x minus 1 equals, equals 0.5. Solve for x.